So for my individual project, I chose to investigate powering fans. The fans we see today can be powered by a variety of sources. It can be wind, they can be plugged in an outlet, or they can be connected to a battery for handheld ones. Now on the go, people mainly use handheld fans to cool down, just because it's portable and easy to use. If it's a really hot day, how can we make a fan go faster to cool us down more? And so one way we can do this is to change the batteries fueling the fan. And so I investigated this by seeing how is the voltage of the battery going into the fan impact the speed. So personal interest with the summer coming up, it's going to get really hot outside. And at this time, fans are going to be very useful in cooling me down and keep me from being overheated. And so if a fan moves faster, there's more air being blown to cool us down, um, making sure to keep us from overheating as well, even more. So how can we possibly increase the speed of the fan? And in terms of social and cultural significance, electric fan technology began in the late 19th century with the invention of the electric motor, and only further developed and continued to develop until the 20th century when it became commonplace in households. And even today, as it developed even further, we can see them everywhere. We can see them on the go, portable handheld fans. We see them in our kitchens with the exhaust fans and even ceiling fans in just about every building we walk through. So how is fan speed typically controlled? Fan speed is typically regulated in modern electric fans through switching between resistors in a simple circuit, with some resistors having more resistance, some having less, depending on the speed you want. But the voltage being supplied to the circuit by the battery is always the same. And so as a resistor's resistance increases, less voltage goes into the fan, since voltage drops across resistors within a series circuit. And since less voltage going into the fan, this will mean that less power is going into the fan as a result of the P equals I times V equation, leading to a lower fan speed as a result, and vice versa. So for my experiment, though, I just changed the voltage directly instead of using different resistors. So I connected the fan to a battery in series. I used, or different batteries with different voltages. I used tracker to count the revolutions per second of the fan frame by frame. I use a voltmeter before each trial to check the voltage of each battery. And so my independent variable was battery voltage and my dependent variable is fan speed. So scientific reasoning, the fan is in series with the battery with nothing else. And since it's the only object attached to the battery, all the voltage from the battery is going to the fan. So the voltage across each of those things are equal. And in looking at the power equals voltage times current equation, as a result of that voltage, the more voltage in the circuit will lead to more voltage going into the fan, meaning more power is going to the fan and a higher fan speed as a result. So here are my physics models. On the left, I have a circuit diagram. As you can see, on the top, I have the fan as a circle, and on the bottom, I have the lines indicating the battery. And so you can see they're all in series and with nothing else in it. So all the voltage from the battery is going directly to the fan and nothing else. And you can see it more on the right with the power box. All the voltage and all the current from the battery is going to one place, the fan, and all the powers as well as a result. So here's my data in graphs with different voltage values and different fan speeds for revolutions per second. And on the right on the graph, as you can see, there's an increasing trend between voltage and fan speed. So some of my potential sources of error for this experiment, batteries could have ran out of voltage as they powered the fan. I had to reuse some of them throughout the experiment, so later trials may have less voltage going into the fan than earlier ones, but I always made sure to double check the voltage before each trial. So that mitigated that error. And I also had to hold the AA battery up to the battery holder since it was smaller, so it could have slipped off positive and negative ends of the holder during the trials, which could have disconnected the circuit. And this may have slowed down the fan at certain points during the trial as a result. Maybe during times I was looking at the fan speed. And for statistical error, I got a standard deviation of 1.069. And it's from the data I plotted on the graph. So in conclusion, I found that as voltage in a circuit increases, fan speed increases. But this only goes up to a fan's physical limit for speed, as it can only go so fast. So if you have too much voltage going in, the fan might short circuit, and that's really dangerous. So if you want to, if you want to be cooled down more summer, maybe try adding batteries with higher voltage to your fans, but do it safely as it can short circuit. So here are my sources, and here's my class question. Thank you.